Alan is the CEO of Eco Design Consultants, which is a specialist architectural organization who really concentrate on having extremely well insulated buildings and looking after the environment. He's a specialist in passive house, which I won't explain because he will, but it fascinates me. It's a building that's almost doesn't cost anything to heat. He's been interested in social and environmental sustainability all his working life. He's a university lecturer. He speaks at conferences all over the place. And probably the most exciting thing from our personal point of view is that he inspired Eddie and Rosie to do a very, very deep retrofit on their 1850s cottage, which is now complete and which apparently saves, how much percent did you say? 60%?
60% is the target. We've yet to see it, have it long enough to prove that, but we think we're looking good.
Well, that's absolutely fantastic. So we look forward to hearing more about that. So enough from me. I'm going to hand over to Alan, who will show slides, speak to us for 20 minutes-ish, and then we'll give you the opportunity to ask questions. Over to you, Alan.
Fantastic. Thank you, Jane. I'm going to be quite quick, so I have got quite a lot of slides, but I will whiz through them. So I think, again, you can always come back and look at these later, so I'll go fairly quickly. Just a quick selection of some of the projects that we've done. Sorry, just move that out of the way. Yep, so we've done everything from new builds, being one of the most airtight buildings in the country in Milton Keynes several years ago, to Passive House Plus, which basically has renewables on the roof, which is basically enough to power the house and the car, and not worry too much about generating electricity and costs. And various retrofits. So a selection of retrofits. Some we've managed to get to full passive house, which is quite an achievement. Some we've aimed at, like this one in Oxford, to get to nearly full passive house, even with internal wall insulation, and just failed slightly just because of the air tightness. We didn't get down to the required 0.6 air changes. We only got to 0.9, which is still fantastic. And other retrofits, including my own house, which I'm talking from at the moment, which we're retrofitting in stages. That's on the projects. Retrofit is really, really important. If we're going to get anywhere near trying to reach our 2050 targets of zero carbon, and that's already, or 2020, 80% of the houses which will be around in 2050 have already been built. So we have to look at retrofitting existing houses, and our stock is particularly poor, as I'm sure everyone's aware. One of the things I love about passive house is really it's not just about reducing energy use, which is fantastic, but it's also about health and comfort. It's about really doing a good job in terms of building physics and building things well. Passive house does have criteria of low heating demands, air tightness, overheating, and so forth. But one of the important things, which is often not known about, is the surface temperature. So a surface temperature should never go below 17 degrees centigrade. This means that there will be no condensation of mold, no cold surfaces radiating cool from there. So it's all very, very comfortable. Also, with the air tightness and the ventilation, it means that all external pollutants are filtered, and also any internal pollutants, again, are expelled through the ventilation systems. And basically, you end up with warm, comfortable buildings that are healthy and comfortable all year round, including summer. So we spend a lot of time looking at the overheating risk as well as the underheating risks. So it's a really important thing, particularly to this time of year, to make sure that houses don't overheat. Alternatives, really, if you can look at ways of reducing carbon that don't necessarily address some of those other issues, and you end up spending maybe more on fuel because you've got renewables and you're changing from gas over to electric. Even with a heat pump, you're still probably spending similar sort of amounts of money, unless you look at reducing improving the efficiency of the building, basically. So moving on quickly. The other thing I really like about sort of the passive house and the methodology really is it works. This is a graph showing a number of house types that have been measured, both the energy prediction and actually how it performed afterwards. And quite shockingly, the red being the ones afterwards, it's actually on average about 2/3 worse than it says. So your EPC basically isn't true. It's probably about on average 2/3 worse than it says it is. But what's interesting is the passive house ones down here, there are really small little ones at the bottom, much closer in proportion to the predicted. And this has been shown again with other surveys. The big question that I often get is, I know benefit passive house, that's fantastic, but it's far too expensive. What about if I only do a small amount of energy efficient? Maybe I put 50 mil of external wall insulation on. What you end up with is you end up kind of chasing with a shallow retrofit. Okay, you are reducing your carbon emissions. That could be, you could do quite well. You're probably looking to do small amounts of things and moving over to a heat pump. So you're going to increasing the demand on the heat pump, increasing electricity demand. So more issues with grid storage, probably small amounts of change in the energy bills, because you're moving from gas to electricity being much more expensive per kilowatt than the electricity, even though is getting closer now. Or the other alternative is the deeper retrofit, where you will be able to look at reducing your carbon emissions, not increasing too much the demand for renewables and the electricity grid. So storage becomes less of an issue. Also, you can, with a more stable insulated environment, you can heat the building whenever you want, really. So you could take advantage of your electricity cheap rate at 12:30 at night to heat your house further the rest of the next day. So there's things like that that you can do once you've got a nice insulated building, and it's more effective for heat pumps. So what we would often recommend, where people can't necessarily afford to do the full retrofit, is to look at doing it in phases. So if you do a shallow retrofit, you're kind of locked in. If you do 50 mil of insulation and render on the outside of your house, that's kind of it, really. You're not going to take the render off and do more insulation later. It'd be very expensive. So really what we suggest is that you do a deep retrofit, plan it out, and maybe do different bits at different stages, so that you can make sure that you can get to where you need to get to eventually. So what this means is basically doing a whole house retrofit plan. And as architects, we like to include the architectural changes as well in that. So being ready for later stages of life, being ready for other changes you're looking to make your house more livable and fit for what the future holds. So including those sort of things in your retrofit plan as well. And you can get this certified at various stages as well through Eurofit. I'll quickly go on to that. So whole house plan is really what we would kind of recommend, to work out what the house can do, how far you can go, and then split it up into affordable chunks and bits and pieces as you go through. So you're really ready. So if the boiler breaks down, you know either what you're going to do afterwards, whether you stick some insulation behind it before you stick it back, on all those sort of things. So you can take advantage of those opportunities as they come along, and do things. Quickly, I was going to go through my house here. So this is the house when we moved in back in, it's a good 19 years ago now. My son was born here on his 18th birthday, just last week. It was in need of work then. And we wanted to reduce our impact on the climate. We wanted to be comfortable. We wanted to showcase it, because that's the sort of thing I was interested in doing. Single glazed and so forth. We did some analysis. This isn't analysis on my house, to be honest, but I didn't put mine into a report. I did all the numbers and the stuff, but didn't do the report. So this is our typical type of report, where we analyze various elements of improvements. So here we're looking at the external wall insulation, modeling a number of different types of insulation. As you increase thickness, how much that improved the building as a single element. So on this house here, it was a 33% improvement. Looked at air tightness ventilation. That basically was achieving about a 26% improvement, just as a standalone item. Combining it all together to get to the Enefit standard was a staggering 92% improvement. So fantastic. So our house, existing, we measured it. So this is where all the losses were. So quite a lot through the walls. even though it's cavity wall construction with some cavity wall insulation at 223. And we were aiming to get down to the passive house retrofit standard at 24 kilowatts, which is an 89% improvement. We then split it into phases because we couldn't afford to do it all. So phase 1, which is basically what we've completed now, which is the first floor external wall insulation and windows and so forth. And we've actually gone a bit further now. We've actually got 1.5, I think. So we've done ground floor insulation windows as well. So that was at 76, 66% improvement just in that first phase, but ready to move on. So just quickly, I was going to go through some of the principles of kind of energy efficiency. These are passive house principles, but they kind of cover for everything, to be honest. Efficient shape, this is something that I think is pretty important. Just to kind of explain how important this is, we did some work for the NHBC Foundation, which is the charity arm of the NHBC, the insurance company, and warranty for new buildings. They give all their money to the foundation, or their profits, which then commission people like us to produce these documents, which you can download for free off their website and help educate the industry, really. So if you take two building types, you take a mid-floor flat and a bungalow. These are kind of the extremes, to be honest, of the building. You open them up, so you see the pink areas on each of them is where the heat is being lost. It's the surface area of the building that's losing the heat. So on the bungalow, that's 279 meters squared of heat loss area for this 93 meter square bungalow. Take the same unit, exactly the same orientation, insulation, everything else is identical. Make it into a mid-floor apartment, which is the best in terms of form factor. 74 meters squared of heat loss area. We then measured it in SAP, which is standard assessment procedure for the EPCs. Current building regulations, the mid-floor apartment, 2,000 kilowatts a square meter to heat. Sorry, 2,000 kilowatts a year to heat. The bungalow is 4,500 kilowatts to heat. So over double. Both exactly the same. And probably the difference is probably even bigger by the time you take into performance gap into account. So you can see that the shape of the building makes a huge influence on the energy usage, but building regulations completely ignores it. Okay, that's number one. One of the things that we often do in terms of shapes on retrofits is a lot of, maybe some of you guys on the call now have a Victorian Edwardian house or something. The front wall door is slightly recessed, so a little external lobby, so you can stay out of the rain when you're opening the door. If you move that forward, so you move that forward to the face of the building, if you were fully retrofitting, that could save you 12% in terms of heat loss. Just a simple change like that. Much easier to insulate, much easier to make airtight and all sorts of things. So looking at the shape of the building is often our first call. For us here, we did to a slight extension, but it's a slight change. It wasn't that much we could do to change the shape of the building. Second principle is insulation. I think everyone knows that, your big duvet of insulation over the house. Our estate here, we looked at some of the other neighbours. Some of our neighbours basically have timber cladding to the top half of their buildings. Our house is more like this one, which has some timber cladding, but not all over. So I thought, okay, I'd like to do external insulation because I know that if you do externally, it won't have the same condensation risks as doing internal, and I won't get a small house. So it made sense for me to go external if I could. So I thought, okay, we can do that upstairs. So that's what we did. So we basically wrapped the house with an air tightness membrane, stick on one, formed a timber framework and basically filled it with insulation. This is on the top half of the house. And we then extra membranes and we clad it with a black cement broad timber lookalike, so it should last for many, many years and won't be fireproof. And looks quite good, I think. The other thing to notice here is we insulated over the window frames on the outside. The windows open inwards. As you can see, this is completely flush. The idea is that the frame of the window is one of the weakest points thermally because it's the thinnest and the least performing. So covering over as much frame as possible allowed us to improve the performance. And to be honest, architecturally, I quite like it as well. with my architect's hat on. We also did some insulation below ground. So if you are looking at external wall insulation, do make sure you insulate below ground. So this was a section on the rear of the house where we're going right down to the ground. We could sneak a bit more external insulation on it. So it is important. Otherwise, it's a bit like going out skiing without your socks on. So do make sure you do it. And that's kind of what that little bit of cladding looks like now. So we had some vertical battens to make a bit of interest, to jazz it up a little bit, and to hide some more insulation. We also now, we're just starting on the second phase, which is the downstairs, but we're doing internal insulation so we can keep some of the brick on the ground floor. So this is a little bit of insulation we've already done, and need to go on with this, to be honest. So we're using 175 millimeters of a high performance mineral fiber, which is, to be honest, more than we would normally recommend. We'd normally you need to be really careful that you don't over insulate inside, because what can happen is warm, moist air passes through to the outside of the house. It will get to a point where it will condense and form condensation, potentially then rot or mold or other things. So we need to make sure that that dew point is further in. Having too much insulation here would probably look at potential risk here at this 175 millimeters. But what we're using here is a very clever membrane on the inside. There's lots of quite clever membranes, which you probably know, like Gore-Tex, which allows water vapor through, but not air, because water vapor is actually smaller than air. But this membrane is the only one that will let moisture through in one direction only, a bit like a cactus. So a cactus will absorb moisture from condensation in the mornings when it's cold, and then hang on for it for dear life during the hot day. So this does very much the same thing. So it will allow moisture out, but it won't let moisture in. So we can do a bit more, but be very careful. I'll be particularly careful if you start looking to insulate your homes with insulated plasterboard, which is what most builders would probably go straight for. If you look at the requirements for it, it requires a ventilated void behind the insulated plasterboard. This often isn't ventilated because they just slap it on. They don't then drill holes through to the outside or through to the inside. And again, if you put holes through it, you're kind of defeating the aim of doing it. And even if it wasn't ventilated, you still would get air movement behind that can move heat around and lose heat. So particularly then when you stick electric socket in or other things. So I would really be careful of avoiding those things. A small amount is fine. So if you've got a house and you've put 50 mil on, that's probably fine. You still got enough heat going through to make sure that dew point is further away and that you haven't got a problem. Alternatives to that would be things like a wood fiber insulation board, so a vapor open material, a cork and lime render system like the diathanite, or like I'm doing, a mineral fiber, again, that's open and maybe in a timber framework. But do think about also vapor control layers and things as well. Third principle, so I'm really rushing here, so hopefully it's all making sense, is reducing thermal bridges. This is something that often isn't thought about really when you're looking at buildings. Hopefully it's a little bit more these days, but this is where basically shortcuts that heat can escape. So a typical thermal bridge might be a piece of steel work that goes from inside to outside. That steel can transfer heat very well, and it will just take all the heat through. So you get, if you had a steel from the outside to the inside steel will be very cold, likely to get condensation and mold on it, and also losing heat through it. So you really want to be careful about these things. One particular thing is if you're looking at doing external wall insulation, like the picture below, if you had this is a planned section through the wall, so just slicing through the side of a window frame. The red here represents the brickwork, basically of the existing building. The pink on the inside is the plaster. The yellow, the cavity wall insulation, assuming there's a bit, it's broken there. And the green being the window frame, sort of cut through the frame of the window. And the orange on the outside here, some external insulation. What will happen is if you left it like that, all the heat will just go straight around the brickwork because that's the easiest path. That is the equivalent, we did some calculations to work this out, of not insulating this red area around that window. So 6.3 meters, 6.34 meters squared of wall you could have just almost not bothered about doing in terms of the heat loss. And you're probably also going to get cold and mold and other things growing on the inside. Classic place for finding mold around the house, I'm sure you're aware. If, however, you move that window out to be in line with the insulation, there is still a bit of thermal loss, but that reduces down to just 0.34, this green area here. So much, much better. So keeping things in line, keeping that distance is really, really important. So I'd really encourage you to look at, when you're doing stuff, doing it well and making sure that these sort of things are considered. On our house, one of the things that we did was when we stuck the membrane to the external brickwork, we put on these plastic GRP brackets to hold the framework. So reducing that thermal bridge for the timber we produce through the insulation. You can see there the brackets at first floor level. The floor is just behind there. And we also did them up at the top by the eaves to basically hold this framework in place that would allow us then to insulate and to hold the cladding on. The windows went in, so for good windows is really important as well. So here we can see them being projected out into that insulation, like I said, for the thermal, to reduce the thermal bridges. The other thing with the windows is that they're triple glazed. The main reason for that really is to keep the surface temperature higher, so within that at least 17 degrees, so within 4 degrees of the room temperatures. So there's never noticeable air movement from the cold glass to the rest of the room. So it's incredibly comfortable all year round. It's the air tightness membrane going on. We then stripped the roof off and we put an air tightness membrane over the roof, ready for some innovative roof panels I'll show you in a second. That's the back. Unfortunately, the roof panels that we were helping develop got delayed. This was partly COVID, partly through to this was the first time we were testing these panels, and there was a few issues with the manufacturer. So it got delayed by 6 months. Unfortunately, we were hoping to put the roof back on during the summer. It then got to the winter. So what now happens is we had the external membrane, which is a vapor control layer, was on the wrong side of the insulation. This was on the cold side, so there's no insulation. So what's happening is you're getting condensation forming, and you can see the amount of condensation was forming. So this is kind of a warning to say, look, be careful. If you do this wrong, this is how much water you might be producing in the wrong place. And I was having to mop it down. Everything's cool now because we've got the panels on. We're now nice and warm, and this won't happen ever again in this house. Once you've made it airtight, and you could see earlier the great improvements from reducing the air tightness is really useful. You need to ventilate. So a good form of ventilation is really important, and it's something I'd really highly encourage you guys to do. This is a Zenda Q350, one of the good passive house ventilation units. Basically, what we're doing is we're bringing in air from the outside that's then preheated by the stale air going out, so the heat is transferred from one to the other, and that's being circulated into all the bedrooms and the living spaces and extracted out from the bathrooms. So this machine itself is about 92% efficient. So overall, really, really efficient. So these are some of the ducts to distribute the air that were put into the loft space before the roof panels went on, including silencer boxes between rooms. So there's no crosstalk between rooms. So you can't hear my family in the other room right now. We managed to hide away all the ducts. So this is one of the ducts, probably the most exposed duct in our airing cupboard going through. So that again helped really well. So just sort of pulling this all together, this is some calculations did for a different property. So again, getting to the benefit. So this other property started about 220 kilowatts a year on the heating demand. We changed the shape a little bit and made it slightly more efficient. We then got lots of insulation. So the insulation was a large proportion of this property. We reduced the thermal bridges, so a nice little chunk there. Put triple glazing in. They had relatively okay double glazing, so not that much difference, to be honest. So more about comfort than necessary energy savings. Made it airtight. So a big chunk there. So way more than triple glazing. Put in efficient ventilation, again, more than the triple glazing. So people often think that the ventilation isn't going to necessarily achieve that much. And it's achieving lots of stuff. So it's not just about the energy savings, it's also about the humidity. So getting humidity into a much nicer zone in terms of health and well-being. Do all that and you get down to 25 kilowatts per square meter. And comfort is just so much nicer. And minimal heating and cooling. It's all good stuff. So just a couple more slides now. So these are the panels going onto my roof, which had integrated solar PV. So this is a stick-on film. And underneath we were running a water system to try and help cool the PV, making it more efficient, and then using that water also to help heat the house and to provide hot water. So this is my son's mezzanine. By doing those roof panels, it meant that we could cut away the roof trusses, so the room I'm in now, and allow basically a new space in the loft. And that's the room there, and then you can see behind. Downstairs, had a bit of fun. So we've introduced a reading sort of bay window onto the side of the house, and that's kind of the rear of the house as it is now. So I think quite a big improvement aesthetically and performance-wise, hugely. As well as some internal changes we've done. So that's about me done. Just one quick plug here. If people want to come and see this house, we're actually opening for the Passive House open days this weekend. So Friday, Saturday, Sunday. I think there's a couple of spaces left, I believe. If people want to get in touch, then you're most welcome to. Yeah, and if people want any help in terms of helping to reduce their houses' energy efficiency, then we're here to help, really. If you want to experience Passive House, this is a new build Passive House. That's actually a B&B, so you can actually go and stay in it if you wanted to. Thank you. Any questions?
Lots, I think. First of all, thank you.
Okay.
I think telling the story of your own house made this very, very much more, I don't know what word to use, palatable, understandable than
Yeah, I agree.
lots of graphs and stuff. So thank you very much for that. I think that's been really terrific. So can I assume that I can share your phone number and email address and all that kind of stuff?
Yes,
with
no
everyone?
problem at all.
Okay. So do you want to stop sharing and then we'll be able to see,
Yeah, no problem.
faces and see who's got questions. So there's lots of chat here. So Eddie, I'm going to ask you to get involved at this stage to put some of the questions together.
Okay, I think Alan may well have answered some of these questions as we went along.
Yeah, I think so. Yeah.
But I'd like to pull up the first question from Willem and from Jackie, where they asked, doesn't one need ventilation to avoid mold? And I don't know, Willem, Jackie, you could maybe just wave if you think that's been answered in the last section.
Yeah, I think it was saying that you do need ventilation. I never understood that these houses had these ventilation systems.
I'd highly recommend, if you're doing this, to put it in as early as you can. It's quite interesting. There's been a whole load of passive house designers who've been doing their own houses and sort of blogging and talking about it. And most of them have not put the ventilation in early enough, and they've all said they wish they'd done it earlier.
Yeah, can I just add?
Incredibly important.
I'm from Norwich, and have you heard about the Goldsmith Street development, which has got national awards? Well, the rumours are coming that they got mould.
Really?
Yeah, that's just coming on the street. Yeah.
Is that because they've turned the VHR off? Possibly.
I don't know, but yeah.
But and the other really important thing with the ventilation is to make sure it's done well. You want to make sure it's designed correctly and installed correctly. Otherwise, you might have a noisy machine that does get turned off, which is quite possible, because people sometimes think, oh, that's using energy, I'm going to need to turn that off. and the consequences are way worse, and they're incredibly efficient. I think the machine runs about 40 watts, so that's pretty much nothing, isn't it?
Yeah.
So yeah, you really need to ventilate.
Willem, you also had a question about the depth of insulation.
Yeah, so I've heard on external walls that that is quite deep, the insulation, and it has aesthetic considerations, how or the look of the house with this. So I don't know what the depth is, but are there cosmetic considerations?
Yes, there are, and again, it can cause issues around windows, particularly. So sometimes you have a window in the corner, and you're trying to externally insulate, so the window has to get smaller. Usually, we can get around that sort of problem. With my house here, we've done 200 millimeters of insulation plus the cladding, so it's about 250 overhang. And to be honest, I really like it. Most people think that's going to be quite a problem. I'm looking at putting some lights up around it at Christmas and other things, a bit like a boy races with blue lights.
Yeah.
But I think and again, the other thing that sometimes comes up with things like bay windows. What happens with the bay windows if you're trying to extend the insulation around the side of the bay windows? What we generally do is you go round the bay windows, so everything goes out. So the windows go out as well, because like I said, you move the windows out into the insulation. So it all just gets a little bit further out. And if you're also going up over the roof, that also deals with the detail at the eaves. So everything just gets that little bit bigger. And to be honest, you don't notice it, I don't think. It is quite surprising. I mean, some of the images on the first one in a street in London, Terrace, we had 200 millimeters external insulation on the front of the house. And to be honest, looking down the street, it was difficult to spot it, which you'd have thought.
Yeah.
The only difficulty we had there was that it had quite a small garden at the front for the bins. So it got a little bit too tight for the bins, to be honest. So the wall had to go. But yeah, I think you can usually do something quite nice. And it's, to me, as an architect, it's how the aesthetics is going to improve. And you can kind of give it a facelift and do something different. And if it's a old historic building, like some of the ones we work on now, you might be doing internal insulation and preserving those things. And again, you can use the box sashes to make sure that the frames of the windows, which might be a little bit thicker, are pushed into the reels, so the frame widths can stay as it traditionally would have been. So you can really try and bring back some of the traditional stuff in it as well, which can really, I think if it's done well, it can work. But thank you.
Okay, a question from Timothy. Do you foresee any issues with the effectiveness of external or internal insulation in areas of the UK where there's a lot of rainfall?
Yes, it's all about the quality and doing it correctly. External wall insulation, which has been done in the past, has forgotten, I mean, the Green Deal and stuff like that, ignored the insulation below DPC. And it kind of ignored how you deal with the junction to the roof. It's all about making sure that insulation is continuous. And as it's continuous, you make sure the rainwater and everything else is dealt with at the same time. What has happened on some schemes, which is terrible, is they put external wall insulation on, they then put an aluminium capping on top. And in some instances, that capping, unfortunately, has tilted backwards. So rain has come down, the water's gone down into the brickwork, caused it to basically water to come into the brickwork, get wet and fail. So you do need to be careful about how all this stuff is put together. But if you do it properly, it's fantastic, because you're dealing with a lot of the issues by getting the thermal insulation on right. You're reducing the thermal stress on the building, because it's not going to the extremes as it was before. It's much more stable. And if you're doing it well to get the air tightness, chances are you're also getting it well to stop the rain and other things happening. So there's lots of other benefits, that anecdotal stuff, that show that the buildings last much longer and better.
Just a question from me on this, Alan. How would you've talked about some of the risks, and clearly something done badly can be very bad. What is the way of de-risking the project so you don't end up with one of these poorly implemented projects?
It's about making sure that you've got people on board who understand what it's all about. So I would highly recommend going to someone, a passive house designer, someone who's on that list, someone like us who is doing that. There are a whole lot of retrofit coordinators that are being trained at the moment, who are trained on all of these risks and stuff. Unfortunately, a lot of this, I mean, like many government programs, it ends up trying to do too many things and getting so risky that it reduces down, and people end up doing small amounts of measures because they're not qualified to go to the next levels, which is really annoying. But yeah, you do need to and talk to people. Just make sure. I mean, I'm here to help. I mean, if people send something through, I would willingly look at stuff and make sure that it's being done correctly. We want to make sure that these things happen. What we don't want is kind of people doing these things, it going wrong, and then you get the horror stories, and it all goes, and then nobody does anything, which is just a real disaster. So yeah, have got to be careful, but it's not rocket science. It's about doing a job well.
Okay. Right, well, let's move on to a specific question from an interested member of the audience. Jackie says she has 3 challenges. 1, a lot of floor area with warm air ducting underneath. A wood-lined roof with limited insulation and no plaster on the ceilings. And a lot of large windows, currently double glazed. Where should she start? Oh, and by the way, she's in a conservation area.
It's not an old house or Victorian house. It's a house that was built in the 1960s, and it's reasonably well built, but it leaks energy like you wouldn't believe.
Yeah. Interestingly, to be honest, it's the 1960s are probably the worst performing houses. The Victorians and the Edwardians were actually often better performing because for 2 reasons. One, they're probably solid walls, so there's less drafting because the cavity walls can cause lots of drafts. And the second thing is they were tight in terms of their material usage. So the form factor, the shape of the buildings is more compact. So yeah, it's not. Yeah, where do you start? The thing I'd say you start with is a plan. So get some calculations done, work out where you can get to, and then be ready for those opportunities. I think otherwise you kind of go off in all sorts of ways and you might then regret. I mean, I did it here. I insulated our wall between the house and the garage with a little bit of insulation. I knew I couldn't do too much because of interstitial condensation, so I limited it. And now I'm taking it out to replace it, which is a bit annoying. So I'm putting more in because I'm doing some on the garage side as well. So where would you start? If there's kind of 2 levels of things you could do. There's the bigger picture. So when you're doing something, do it well. But in the short term, there's some short gains would be reducing drafts. So reducing drafts can be really effective in terms of reducing your losses. So around windows, so 1960, so you haven't got dot and dab, which is fantastic. So dot and dab is one of the more recent things that most builders again will do now, which is terrible in terms of air tightness because there you can just go behind and escape through. So you haven't got that probably, so that's probably good. So you've got a wood-lined roof in the loft. Is it a room you use in the loft?
We don't have a loft above. Essentially, we're on one level, so we're kind of like a bungalow with about 50% bungalow, 50% 2-story. The 2-story bit is 2 bedrooms, and neither of them have ceilings. It is completely wood lined.
Okay.
So we don't have a loft above at all.
Okay. So what I would probably find is that's probably very air leaky. So there's probably lots of air going up through there and heat is escaping. The roof also generally rises. So again, it's a big area, lots of heat going out through there. Probably what I'd recommend doing is taking off the roof tiles, stripping that all back, taking off the tiles and the membrane, putting a membrane up and down through the roof back to the timber. So you can see that. So that becomes the air tightness layer. That's all then taped up to other things later. So you need to be careful, making sure that's still available for joining up later to other things.
Yeah, the other problem we've got is that we don't have standard tiles. We've got these big concrete roof tiles.
Okay, yeah, that's okay. They should come off relatively easily then. Then insulate between. So I would use a fluffy insulation between it. Then I would then put on a rigid insulation board. Possibly, actually, to be honest, you could probably get away with putting, if you put enough insulation on the outside of it, having your air tightness membrane directly over the roof trusses, like I've done here, to be honest, like that membrane you saw on my house.
Yeah, yeah.
More insulation on the outside of that, then another membrane to keep the rain and the wind out, all taped up, so then you don't want air and wind and insects getting in. Then battens and counter battens. So you have 2 layers of battens, then put the tiles back on.
Right.
So you are going up probably 150 millimeters, so at the ridge even more. So you will need planning. One of the annoying things is that it's permitted development to increase the thickness of the roof, but not the ridge. So you could, for the permitted development, go up and have a flat top, which would be stupid, in my opinion. But you need to get planning permission to get that done. So that's
fine.
Probably, and you could, to be honest, at that point, you could say, okay, you know, those tiles, I don't like them. Let's do something new. Maybe.
Yeah, we can't change the tiles.
Maybe put some PV up as well while you're doing that. So maybe inset the PV into the roof. If you can get your conservation officer to agree, it may be possible. There are some conservation officers who will.
Right.
Good luck, Jackie.
Thank you.
Okay.
And later on, maybe reduce the windows down a bit, because the 60s they did do far too bigger windows, and you're getting rather hot at the moment.
Yeah. Oh, especially because our living room that's under the 2-story bit, the roof actually goes all the way down almost to the ground. We've got sloping windows.
Okay, yeah, that will, if it's facing east or west, then that will.
Fortunately, we face northwest. Otherwise, we'd be a greenhouse.
Okay. Yeah. The other
we've got lots of other questions, so we better.
Yeah, last bit on the windows. By going to triple glazing, you'll reduce the solar gain, so it'll actually be cooler in summer as well. So that's another advantage of the triple glazing.
Okay, so quick question. I'm just looking around the audience here tonight, and I guess quite a lot of them might ask this question. Will we live long enough to get a payback?
Oh, I love that question. It's how you define payback. That's the big question. If you're purely looking at the cost to you in terms of energy bills, then no. But I would say that you're probably going to live longer, because you're going to have a more healthier atmosphere. It's going to be more comfortable. So you're probably going to live longer. How much is that worth? I ask. And you've also got to think in mind, which often these calculations don't include, maintenance costs. So here I had single glazing, they need to be replaced at some time. Here the timber cladding was falling off, need to replace it. So there's a whole load of maintenance things that you need to bear in mind that you may be just bringing forward to these costs, and the cost to the planet as well. So do think about how these things, payback periods, work. It is getting better. With fuel prices going up, the payback costs are coming down. Also, interest rates are going up, so you could invest in other things. So that's also that's going up rather than down in terms of the payback periods. So you just need to think about it in a slightly wider way, I think.
Okay, so it's not just the money. Think about the lifestyle and everything else on the planet.
And the societal things. I mean, you'll find that by having healthier buildings, people are happier. They're not such a strain on the NHS. So I mean, if you start looking at the costs of the NHS and other things in terms of healthcare, these things pay for themselves. But obviously, we can't get a check from the government to help pay for these things. You wish you could.
Okay, back to a really practical question. How do you this is from Kate. How do you deal with external installation on a semi-detached house?
I'm not sure why it's more difficult in a tiny house. It's the same as you do with everything.
Yeah, I think the problem is, doesn't it look odd if your neighbour doesn't do similar?
You potentially, yes. So semi-detached. Sorry, I missed that bit. Yeah. So ideally you want your neighbour to do the same thing, but you can. We have done stuff. We've got examples on our website where we've done a similar sort of brick color render. I'm assuming it's brick. You can use brick slips, Brick slips are a bit expensive at the moment. So they're very thin bricks that you kind of glue on. And you can do other claddings and stuff. But yes, it is a question of how you look at these things. So as architects, we look at that all the time in terms of how we can get it to look as good as you can. It doesn't have to be white render, to be honest. That's often what people think. It is probably the cheapest option, but yeah, it doesn't have to be the white render. But yeah.
Okay, so and Kate also said, can you give some idea of costs?
Yes, costs are all over the place at the moment. So I mean, typically our projects, which are quite large, sort of 4-bedroom houses, often detached, and we're doing other changes as well, we could be spending £300,000 on them, if I'm honest. House here, we're spent, I think once we've finished doing the bathrooms and other bits and pieces that we're good moving things around, then they needed doing anyway, we're probably going to be spending of about 180,000 by the time we're finished. So it's not for the faint-hearted, and we've done a lot of the work ourselves as well. So I'm doing physically doing a lot of work as well to do that. But material costs are high. It's about, but smaller houses obviously would be cheaper, and we need to look at doing this at scale. We need to get the government involved in doing larger things at scale and doing it well. There's all sorts of projects at the moment that just seem to be watering it down each time, which is a real shame. So I'm a great advocate of doing maybe smaller bits, maybe not do everything, maybe don't do your ground floor until later. Do things when you can.
Okay, thank you. A very specific question from Philip. He says he's got a lot of glass, but he's putting in a new gas warm air system to replace an old one because he doesn't think there's a sensible alternative. Is that a good sound view?
I'm just thinking, how is it heated? It was heated with a
gas warm air system.
Okay. Okay, so the real question there is it worth moving over to a heat pump? Is I guess what you're suggesting.
Well, my problem is I don't think that I will ever get the same heat value without spending a lot, because a heat pump does require a lot more insulation in order to maximize the use of it. So I could find that the cost is spiraling to get the heat pump to keep track of the heat. I could spend all of that and still not achieve that without doing something about every other aspect of the insulation. So so my short-term solution is the warm air system I have currently now was installed in the 1980s. And like all things of that age, it was meant to last forever. But it is inefficient, and there's not enough people around with enough knowledge to sort it out. The new system that would replace it is the cheapest alternative, probably cost me about $6,000. And that will be a condensing style one, but it'll use all the infrastructure. I could pull that out and I can't really pull that out and put a wet system in because the house is not designed for that. And that would also be a big retrofit. So I seem a bit boxed into a corner of going broke or keeping warm.
It's probably worth looking at an air-to-air heat pump.
Yeah.
So these are things that don't currently get grants, as you'd expect. Can be a split unit. So these are the sort of things you get in offices. So these can be a small external unit that then has a unit on the wall inside that will put out basically hot air or cool air. It is a heat exchanger, so it will have a COP of up to 4 or 5 even. Some of these are quite efficient. You can buy the units for about £800, so not hugely expensive, and maybe about £1,600 to install. So you could find that you get a very similar output by moving over to electric in terms of energy bills. But depending on the size of your house, you might need a number of these, because you'd need basically almost one of these in each room if it's not efficient. But you could probably look at blocking up some of the air vents, because I know I was brought up in a 1980s house with that air system. It was terrible, to be honest. And I know that some of the air intake is just basically a hole in the floor that goes straight into the floor void to get the air in, which is just outrageous. But so you could block up, you could make the house more airtight, and that would reduce down some of the demands, and maybe spend some of the money on the insulation and other things. That's possibly a solution that's worth looking at. For those of you who have a gas boiler and are looking to move over to heat pump, what you can do, not now, but in the winter, see if you can turn the heating temperature, it's coming out down to sort of 45 degrees. If you can get your house to run and still be warm at 45 degree output into the radiators, you can move over to a heat pump to do that. So that's a good way of sort of stress testing to see if it will work. Probably won't.
Good idea.
I found that I can set my thermostat at about 15 degrees and still be warm in this house.
Okay, that's good.
Yeah, so the insulation is not that bad, but there is a lot of floor to ceiling glass, and it's only double glazed.
Yeah, so at some point it'd be worth you making that triple glaze and probably reducing the size down of the glass as well. So putting in some insulated panels and other things, because you'll find that also the larger glass area is going to overheat as well, I'm guessing. Yeah. So you kind of need to make sure that's balanced. Generally, rule of thumb, 20% of the floor area for glazing for windows. So if you've got more than 20% of your floor area of glazing, then you've got too much.
Okay.
Good tip.
Good figure. Thank you.
We've only got a couple of questions left, so and I know we're only a few minutes to go. Jane, how long have we got?
Unmuted. People are free to go if they want to leave, obviously. But if Ellen's got another 5 minutes, just so that we can finish the questions, that would be great.
Because I didn't realise I had to write a question down, so then it depended on what I heard anyway.
So did you have one you want to ask, Mary?
Yes, because I have I got cavity wall installation some time ago in my townhouse, 3 stories, and it was blown in tiny pellets, tiny balls.
Yep.
I've no idea how efficient it is or not. I mean, I think it is, and also it's a terraced house as well. So I've got people either side, which I think lots of people would be well off with a terraced house because it's use their heat as well. And I wondered, you haven't mentioned the spray insulation for the loft, particularly. I think it's got a very bad press, and I think you'll probably give it a bad press, but I just wondered what you thought about it.
There's 2 things I'd probably add to that. Yes, the spray foam, I would avoid it. It has got real problems with insurances and stuff at the moment. We're actually retrofitting a house in Oxford because of that, which is great because they're now getting a full benefit. So there's some advantages, I suppose. Because what they found is it was basically gluing the tiles on from underneath. You then had the tile crack and needed replacing. Take off that tile, the next one breaks. Take off that tile, the next one breaks. And to be honest, before you knew it, all of the tiles had to come off. So it has been one thing that has actually brought them to us to help develop the whole house. So yeah, avoid the spray foams if you can, I would suggest. The second point you had in terms of being mid-terrace, that's fantastic. I would, though, put a little bit of a health warning on it, in that if your house is probably between the 1980s, 70s, 80s, 90s, and now even, that what was often done was that the wall between the 2 properties was a cavity wall. No insulation in it, not capped at the top, electric sockets and stuff put into the walls, heat through the electric socket, straight up that cavity. As heat gets warmer, it will rise and pull heat through. What has been found is that some mid terraces are actually worse performing than the end terrace if they've got this sort of cavity not capped. And this was still happening for quite some time. Now the building regulations do require that cavity to be stopped at the top and other areas to stop any heat going up. So be a little bit about that. So new properties are probably fine. Probably, I wouldn't necessarily say that they're built as good as they should be, but not necessarily as good. In terms of the insulation, it may have slumped, particularly if it was the white polystyrene balls. What's supposed to happen?
Sorry, these were blue.
They were blue. Okay.
I don't know whether that makes any difference.
They're probably polystyrene then. It's not it's usually either polystyrene or mineral fiber. So it sounds as though it's the polystyrene. If it was a grayish color, that's fantastic because it's got carbon in it as well, which makes it high performance. It may have settled. They may not have put enough glue in it to hold it all together. So you may find it has settled a bit. So you might be, if anybody's got a thermal imaging camera you can get hold of, have a look at winter to see whether it has settled and whether it could be topped up. So it's maybe worth looking at doing that. It's one of the few times I would kind of recommend using a thermal imaging camera, to be honest, because often you can misread some of the findings, and it's not.
Yeah. The local authority in my area did a deal on solar panels with batteries, but they were way too expensive for me, and they didn't give any finance with it, which I thought was very silly. So I haven't got solar panels, but I think what I need to do, somebody says I should put more insulation in the loft, the fiber that you're talking about.
Yep.
The ordinary stuff you can get from Wicks or whatever. Yeah.
400. I would go for 400 millimeters, but also look at the thermal conductivity of it. What you generally get in Wicks and other places is a conductivity about 0.044. You can get much better stuff at 0.032. What I would do is move the current stuff to the middle, and at the very edges where it's thinnest, put some really good stuff.
Right, because this guy who does a lot of handyman person said that he felt that it was all because it's 1980s type house that it's wearing out anyway, and it's not the depth it should be.
Yeah, so do look at the quality of the installation.
Yeah, Mary, well, we're going to have to move on again. We've got a question from Denise, and I think it may be similar because it's a question about any advice for people who live in an apartment. And Denise, I'm guessing you're not in the UK.
Hi, Denise. Can I just ask whether it's a ground floor, first floor, or where you're kind of positioned in the building? Because that could make a difference in terms of what you might be able to do.
I think she may have left actually.
She's in the chat. In the chat.
Yes, she is.
She's in. Oh, yes, because she has a problem with technology today. She says she's in Germany and she's living in the first floor.
Okay, so I'm guessing I'm guessing there's a flat above and below. So there, to be honest.
You're muted.
Alan, I think that was me. I had a finger problem.
Okay, no problem. No problem. So I'm not sure where I got to on that. So basically, I'm guessing there's a flat above and a flat below. So in terms of heat loss, it's relatively small in terms of the external walls. So for me, the big areas to look at would be the junctions around the windows and the walls, so making it as draft-free as possible. And encouraging your neighbours to heat their properties and heat you. And maybe as a whole, looking at as a building itself, maybe looking to doing some stuff in terms of the roof and other retrofit measures. One of the big things, like I was talking before, is about how the windows and stuff are fitted. So if you are looking at getting those done, make sure they're fitted well. I know the Germans have done some fantastic things. Passive House was started in Germany, so there should be some good stuff. So look at the Passive House retrofit stuff, and they've done some really interesting studies in terms of what the government there is putting forward for retrofit plans. And actually, if you go to the Passive House retrofit standard and do it in stages, it's cheaper, goes further, and will last longer. And so it's kind of a real win-win. So I'd really kind of encourage that method and doing things well by things like the thermal bridging detail around the window. It's really where it can make a big difference going forward.
Okay, Alan, thank you for that. Final question. The question is, what does this do, all of this work, do to the value of your house?
Okay, good question. It is difficult to put a number on. Estate agents, as estate agents aren't necessarily the most clued into this stuff. I know from some more recent studies that the Passivhaus Trust has done on new builds that it's anywhere from 5 to 15% increase in value. I have also heard anecdotally that some developers are looking to double their price of their properties they're looking to sell. I would guess though, with a retrofit property, it should be more than the 5 to 15%, particularly if you've now improved the look of the house. There's obviously that can do stuff, and people are understanding these things much more. But it is really difficult to know exactly. You're probably, to be honest, not going to increase. Like, I don't think here I've added the £160,000 to the value of the property. It's probably gone up since we've lived here, the 160,000, if I'm honest. But inflation and other things. So I would have thought it depends what else you're doing, because often you do things. I mean, we've changed the layout a bit and other things like that. We've now got a dressing room, which I didn't have before. So there's things like that that obviously add value as well. So it is a difficult one to answer.
Of course, and it probably has a lot to do with where the house is and what kind of building it is. But I'm actually very interested to know whether it would, and you can't answer this question, whether it would actually make the house more likely to sell as a house rather than as a piece of property, as a piece of land. Because what's happening around where I live is that houses are just pulled down, replaced. But I would have thought if it had been made really, really efficient, that hopefully they wouldn't do that. But I mean, you know, who knows? Listen, we've overrun because everybody has had so many questions for you. And thank you so much for taking the questions seriously and giving them a serious answer, even the ones which were quite personal and people are actually asking you to give them free advice about their own house. So thank you very much indeed. We will make sure that we pass on your details in our literature and stuff so people know how to get hold of you to answer other questions, or indeed to come and retrofit the house for them.
Perfect.
So thank you very much indeed. You've managed to cover a huge amount of information in a short space of time. We really appreciate it.
Very good.